Alright, so here we have a very nice problem from the International Mathematics OLympiad on the Algebra 1. This is a list of long listed problems posed at the Mathematical Olympiads. So here we are told that let n be an integer and that let a be a subset of this particular set here, and a has 4n plus 2 members. So a is a subset of 0, 1, 2 to 5n, and it has 4n plus 2 members. Now we are asked to prove that there exists a, b and c in a. So there will be 3 numbers in a such that we can order them that a is smaller than b, smaller than c, and that this relation is true. C plus 2a is bigger than 3b. Now how do we do this? Let's say we say that n is 1. So that means that a is a set consisting of 4n plus 2. That will be 6 because a is 1. So a will be this set 0, 1, 2, 3, 4, 5 here, because when n is 1 we only have 5 to the first power. So let's pick 3 members from this set. Let's say 3 is less than 4, less than 5, and we are told that if a is less than b, less than c, that c plus 2a should be bigger than 3b, that there must be numbers in this set that satisfy this condition. Let's see if it works for 3, 4, 5. So in this case here, that means 5 plus 2 multiplied by 3 will be bigger than 3 times 4. Let's see. This is 5 plus 6 will be bigger than 3 times 4. This is 11 bigger than 3 times 4. This is not true. So it does not work for 3, 4 and 5. So what numbers should it work for? Let's pick for 1, 2 and 5. Okay. Now in this case here, now for 1, 2 and 5, we are going to see that 1 is less than 2 plus less than 5, and that is it true that c plus 2a is bigger than 3b? So let's see, that will c will be 5 plus 2 times 1. Is it bigger than 3 times 2? So that will be 7 is bigger than 6, which is correct. So that means we have seen 3 numbers here for this particular. For n equals to 1, we have seen 3 numbers, like for which if we take a subset of this bigger set here, it is true that c plus 2a will be bigger than 3b. Now this is only the case for n equals to 1. Whatever the case for n equals to 2, n equals to 3, and n equals to 1 million up to any n, because we are told that n is an integer. So this problem is claiming that this is true for all values of n. Now our task here now is, even though we have shown that it is true if n is 1, we have found an example, we cannot conclude that this is true for all n. So what we're going to do is that we're going to figure out a way to prove this directly. And obviously one way we can do this, let me wipe off the board, so hold on a second. And one way you can prove a result that actually may seem difficult to prove is that, let us assume that this is false. Let's assume that it is false. Let's assume that it is possible that let's say proof, and our proof will be based on contradiction. Our proof will be based on the contradiction. So let's assume by way of contradiction that c plus 2a is less than or equal to 3b, because we consider the case of equality. So if this is not true, then means this must be true as well. They are more like inverses of each other. So let's say we have a set A, like let's say that it is true that if n is an integer, then it is always possible that we can pick 3 numbers so that a is less than b, less than c, such that c plus 2a is less than 3b. Notice that we are claiming that it is always possible for this to happen, because if we are going to be like, if we want to prove that there must be at least a, b and c for which a is less than b, less than c, such that c plus 2a is bigger than 3b. If we want to claim that this is true, that this is false, then means that it is true that it is always possible to pick 3 numbers that satisfy this inequality, and as well has the condition that this is true. So if we can, so by contradiction, let's assume that this is the true case we have there. Now in particular, let's pick 4 numbers. Let's assume that a is a set. here is this set consists of these numbers x of 0, x of 1, x of 2, up to x of I plus 1, then up to x of 4n plus 1, because n is a set consisting of 4n plus 2 members. So we have 4n plus 2 members, and notice there that x of O corresponds to 0 and x of 1 corresponds to the case of 1. So this is a case of 4n plus 2 members. And let us assume that in particular that we have 3 numbers from this set such that notice that x of I is less than x of I plus 1, which is less than x of 4n plus 1, because 4n plus 1 is actually the biggest. We assume that the sets are arranged, so we assume that x of O is less than x of 1, less than x of 2, less than x of 3, and less than x of 4n plus 1. So we assume that 4n plus 1 is the biggest member of this set. So, and this inequality is true. This means that it follows that we should have that c plus 2a is less than or equal to 3b. So what is our c? That means 4n, okay, not 4n, but x of 4n plus 1 plus 2a, that means 2x of I should be less than or equals to 3 plus b x of I plus 1. Now what we are going to do now, we are going to try to compare this each of x of I and x of I plus 1. We are going to try to compare it with x of 4n plus 1, and this makes sense because x of 4n plus 1 is the biggest member of this set. It is the biggest member of this set, so it makes sense to compare each of these small numbers by x of 4n plus 1. So by way of doing that, we are going to try to derive the relation x of 4n plus 1 minus x of I, and then we are going to have x of 4n plus 2 minus x of I plus 1. So we are going to try to see what these relations can give us. Now for that reason, we are going to subtract negative 3 of x of 4n plus 1 here. Yeah, we're going to subtract negative 3 of 4n plus 1 here. This will give us something like negative 3 here. Then we'll have x of 4n plus 1 minus x of I plus 1. So for this right hand part. Now for the left hand part here, we are going to, since we subtracted negative 3, we are going to subtract again. So we have, if we subtract negative 3 from this page, we are going to have negative 2 x of 4n plus 1 plus 2 x of I. So this is what we're going to have as our inequality here. So hold on, let me take off this part. I want to do everything on a single page so that we can always reference the problem we are working on. Like we can always go back to it. Okay, let me put a different color here. Alright, now this means that we can always bring out a factor of negative 2 here. So have negative 2 of x of 4n hold on. So I have negative 2 of x of 4n plus 1 minus x of I is less than or equals to negative 3 of there is no space for us here. Hold on. Alright, so let me just bring it over here. We have a negative 2 over x of 4n plus 1 minus x of I is less than or equals to negative 3 over x of 4n plus 1 minus x of I plus 1. So here we have tried to compare, like this difference x of 4n plus 1 minus x of I generally measures how distinct x of I and x of 4n plus 1 is. Now we can divide both by negative 2 and the inequality gets flipped, and we have that x of 4n plus 1 minus x of I should be bigger than or equals to 3 over 2 multiplied by x of 4n plus 1 minus x of I plus 1. Now this inequality tells us that obviously we can continue further and we can have that x of 4n plus 1 minus x of I plus 1 should be bigger than or equal to 3 over 2 x of 4n plus 1 minus x of I plus 2. And we can continue further that x of 4n plus 1 minus x of I plus 2 should be bigger than or equal to 3 over 2 x of 4n plus 1 minus x of I plus 3. So we can continue further, and this one will be greater than or equal to, notice that this is still greater than or equal to 3 over 2 of this, so this is greater than 3 over 2 squared of x of 4n plus 1 minus x of I plus 1, no, I plus 2 this time around here, and this is greater than or equal to, now to have 3 over 2 to the third power of x of 4n plus 1 minus x of I plus 3, and we can continue further. So this proves, what this proves is that we are going to write it on top of this page here. Okay, let's write it. So what this proves to us is that x of 4n plus 1 minus x of I is bigger than or equal to, now because we are summing from 1 2 3 up until 4n, because we can't have 4n plus 1. If we get to 4n plus 1, this becomes 0, so we are going to stop at 4n. So, and we started with I. That means this is bigger than or equals to, the power of 3 over 2 will be 4n minus I, 4n minus I multiplied by x of 4n plus 1 minus x of 4n. So we're going to stop at this place here. So let me take this off. I think this is not neatly written, so I have to probably write it better. So this is it. So we have that x of 4n plus 1 minus x of I is bigger than or equal to, now we have 3 over 2 to the power of 4n minus I multiplied by x of 4n plus 1 minus x of 4n. Now let's say let's take, this is true for all values or variables we have listed here. So let's take I equals to 0 per se. That means x of 4n plus 1 minus x of 0 should be bigger than or equals to, this means 3 over 2 to the power of 4n. Now we have x of 4n plus 1 minus x of 4n. So but notice that x of 4n plus 1 is bigger than x of 4n, because we have already stated that x of 0 is less than x of 1, which is less than x of 2. So this is less than x of 4n plus 1 is biggest number in this set. Okay, so this means that this is greater than or equal to, this is already bigger than 0, so this is bigger than or equal to, now that would be 3 to the 4 is 81, and 2 to the 4 is 16, I believe. So this is 16 to the power of n, and we have x of 4n plus 1 minus x of 4n. So this quantity alone is bigger than 1, is greater than 1, because these are both integers, and this integer is bigger than this integer, so the difference will be bigger than 1. So that means this is bigger than strictly bigger than 16 over 8. How many times 2 go into 3? This quantity is bigger than 1, obviously. So for 81 over 16, I can't tell. Let me see. Alright, 81 over 16 is bigger than 5. So this is bigger than 5 to the n multiplied by 1, and this is bigger than 1. This shows that x of 4n plus 1 minus x of o is bigger than 1. This is impossible, because by definition s of o was supposed to be less than s of 4n plus 1, and this tells us that definitely our assumption is wrong. So we assume that this is false. So this assumption that this is false is wrong, and by way of contradiction, that means that the statement is actually true, and this proves the statement for all integers n. So thank you for watching the channel, and please do subscribe to the channel, and have a nice day.